Hello, welcome to 1.3.3 networks. Depending on where you are in the timeline when you watch this video, you're either watching it as a recap, bit of revision. You might not have looked at networks, but I know the people that will be watching this in the first instance will have been asked to look at some of these aspects as part of an MS Teams task, and this should clean up some of the definitions, and there's a little bit of new learning perhaps in here as well. So I'm going to crack on straight on with it. First thing to say here is this is a video lesson and needs to be treated as such, which means I'll ask you at certain points to pause the video, maybe jot down something, so have a pen and paper handy, maybe recall something that you've done in the past, a bit of a revision activity, or to research something. It's just little activities that you'd expect to do in the classroom, but in this case, I'll ask you to pause the video. Please do that. Don't just stream through and don't skip along. The whole point is to kind of almost treat it like a lesson and go through with the motions, hit the pause button when I say, and then unpause when you've finished to see, check it with what I go through. Please do that and it'll be fantastic. It should hopefully help with the retention and help with that recall when you get round to having to do the real thing. So from the RAG map, the sections in particular I'm focusing on here are in the 1.3.3 section, kind of looking at networks overall, protocols and standards towards the end of the PowerPoint will be a bit more of a research one for you. We're going to be looking certainly at LANs and WANs, packet switching. We're going to be looking at the network hardware as the bulk of this, which I'm aware I've set for you to do in the past for some of you viewing this, and I want to make sure I go through that. Now, I'm not picking up some of the bits, and I will pick those up in another session, but that's where it comes from. Those elements are picking up from here. So what is the network? First quick task for you. I want you to pause the video and I want you to jot down a couple of lines for what you would do, how you would define what a network is, and pause the video now. And you're back. So you hopefully have got something like it's a collection of devices that are connected together, and you won't get that. That's what kind of like a word that they tend to refer to them as nodes instead of just saying devices. Like nodes are the things connected together, and the main reason for this is to share, to communicate. All right. So as long as you say it's a collection of computer connected devices and that they're just for sharing data, that's what you're after. That leads me kind of to the next slide, which is why networks. So I've given you a bit of a clue. I've given you you're on the right track, that it's about sharing. I'd like you to pause the video and kind of think about all of the advantageous, all the advantages you can think of about that sharing and what that might mean and what that might look like. So pause the video, jot down as many ideas as you can, and when you've exhausted it, unpause and come back to me. And pause, and you're back. So we talked about communicating, things like just normal file transfers, file exchange, working collaboratively on a document, which you can do via things like Teams or the Google kind of platform. You can do that, working collaboratively in real time on the same documents. Think about sharing network hardware, for example, like an expensive printer. Anyone can then have access to that device. Sharing software, distribution of software from a central point to many points. There's a lot of reasons we can come up with it. Networks brings about cost, because if you have a network compared to a standalone computer, you're going to have a lot of stuff to look after, extra hardware, extra cables, and that means, and also extra software to run that network, and extra security in place. That means all the hardware for it, and that means all the software for it, and then maintaining it, paying somebody to look after it. So lots of extra cost. We've also got a little note there about the dependency on networks functioning, because if you have a network, probably there's a collective there of a lot of computers doing a lot of things and maybe storing a lot of important data, and you're going to want levels of things like redundancy in the system in case things fail, failover system, disaster recovery plans. Now these come into another part of the theory. I'm not going to cover them now, but they do link to kind of this thought of networks and why you might need these systems in place. But you can look at those if you like, but I'm just mentioning them because there's something we will need to talk about. So LANs and WANs. Pause the video. I want you to write down what you think a LAN is and what you think a WAN is from what you've covered in the past. And once you've done that, come back to me and pause. And you're back. So, now if you hear any rumblings, by the way, that happens to be guinea pigs, so I apologise for that. Uh, so LAN, local area network. You say a collection of devices which are close together and are connected. Um, you're probably gonna own everything, as in the hardware to run a LAN. So you probably have a switch or a router at the heart of this network, and you'll own all the cables or the fact that it's in one building, and that's kind of the definition. So a collection of computers or devices, nodes, which are close together, connected together, and probably using hardware that you own, is the best way you could define that. And a WAN is a wide area connection, which is where you're connecting two or more different LANs together. So the most common example at home would be connecting to the internet, so to the outside world, and you've got your own little LAN, and you're going to connect to the WAN that is the internet. And you do that because you're going to use third-party telecoms. You'll use somebody like BT or Virgin Media or somebody that's going to supply third-party cabling to allow you to connect to that outside world. And you'll use a router to make that connection, because as you will look later when we look at the hardware, we need to connect one network to another. The router does that. We're now gone from a LAN to a WAN. So we've got that instead of being close together, we're now geographically remote, and that's another part of that definition you can pull in there. The biggest example of a WAN would be the internet. So little pictorial kind of example there. Feel free to pause and look at it, but you can see it's just a LAN and then connecting out to a WAN. So I task some of you to do this at some point, if you're watching this video, to look at some certain hardware. So it's just a quick revision recap activity for you, and if you haven't done it before, then perhaps this is a good chance to sit and just quickly go and research these things online. So there's a list of the hardware you need to be aware of. I want you to pause the video, run down the list, quickly think of the purpose of each of those devices and its role in networking. That could take a little while, so once you've finished that activity, come back to me and I'll just quickly recap them. So pause, and you're back. So NIC, that's your network interface card, or network interface controller, I think they also call it. It provides the MAC address. We'll talk about that in a bit, and it also allows you to assign an IP address. Again, we'll talk about that in a bit, to the computer so that it can connect to a network. So the job of the NIC is to allow the computer to connect to the network. You can obviously get wireless versions of this. They're just called wireless NICs, WNICs. Then we've got our Ethernet, however you want to pronounce it, or network cable. And it's got lots of names. Category 5 cable. It allows you to hardwire the NICs together. So connect one end into the network card, into the NIC, and the other end into perhaps a router or a hub or a switch, to facilitate the communication, to allow data to travel along the copper-based cable. There are other cables you need to be aware of, and I'll talk about them more another time, but optic fiber being one if you want to have a look, but this is the main one for now that we need to think about. And we know about Wi-Fi, or you will know more about Wi-Fi when we look at that again as a focus network. This is a big topic, and I'm just going to go through some of the core of it today. So hub and switch, essentially quite similar in the fact that they are central points in networks which allow multiple devices to be connected together. So if you wanted you and a few mates to have a LAN party and you weren't going to connect to the outside world, you could get a hub or a switch, get all the computers, plug them all into the hub or switch, and then they could all talk to one another and communicate. The big difference between the two is that a hub, when it receives a signal from a connected device, it will then echo that signal and send it out to all other devices, irrespective of who it's intended to go to. The one that needs it will go, ah, that's for me, and take it. So there'll be a bit of unnecessary traffic maybe being fired out. A switch will store IP addresses of everything connected to it, so that when it receives an inbound kind of signal from a device, it will only kind of forward it to the correct connected device, so there won't be as much traffic. So you can think of a switch as an intelligent hub, maybe. It's just got kind of like an address book, so it knows where to send things, but they kind of essentially do the same job. And then you've got a wireless access point, which you tend to plug straight then into a switch or a hub, and it just puts up a Wi-Fi bubble so that things in the area that are wireless can connect then to the wired network and get access to presumably something like the internet and the network resources. It will require some kind of key or some encryption key to get into it, and that's the way those work. And finally, you've got the router, and the router is probably the most important device in your household in terms of allowing people to connect to things within the house, to the internet with any device in the house. And what the router will do is it will connect your home LAN to the outside world, the internet, so you can do that. Uh, Most of us have probably got something that's been given to us by our um, internet service provider, so Virgin Media or BT, and it's likely to be given a fancy name like a smart hub or a home hub or something like that. Its main job there is a router, but it's probably got a WAP built into it, so it's putting up a Wi-Fi bubble as well, and it's got ports on it which allow it to kind of plug hardwire things in, so it behaves like a switch. So it's kind of a one-stop, one-trick pony. No, that's wrong. It's a an amalgamation of all those technologies we just talked about to put it into one box. So one size fits all kind of thing. So hopefully that kind of makes sense. So it connects two different networks together. So like your home network to the internet, it allows all the devices on your network to communicate to the outside world, and get connection to the internet. And you know about that, I've just talked about it. So that's your router. So there you go. There's the main kind of components you need to know about. I mentioned that there's the IP and the MAC address. So I'll give you a quick few minutes to see if you know, and you feel free, you can go out and research this one if you don't know it off the top of your head. But I'd like to know what they are and how they differ. So go spend a while turfing that out. And if it takes you 15 minutes, it takes you 15 minutes. So go do it. Pause the video now. Come back to me when you've had a look at both what a MAC address is and what an IP address is. Go. And you're back. So IP address, you should have got that it's the operating system that's allocating this by using the network interface controller, network interface card, and it's unique to the network that you're on. But it's not unique worldwide, so it's just unique to the LAN that you're on. It's 4 bytes storing a value between 0 and 255, because if you think about it, that's 256 values, which is what you would store with a byte, 8 bits, and it would look like what I've got there, so a sequence of 4 numbers to denote that unique IP address. That would be the physical address then of where it is on the network. So you would refer to it as that. That'd be like your house number. Like I live at 3 Lion Walk. That's kind of the equivalent here. That's what it is. The MAC address is embedded into the device from when it's manufactured. It can't be changed, and it is unique, completely unique worldwide. It helps to kind of really locate that device on a network, and it's usually stored as a hex, and it's usually a 48-bit value, which means if every single combination of that hex value, you'd have over 281 trillion different devices, which that could kind of go across, which is quite a lot. Without the MAC address, you can't actually assign an IP address, which begs the question, like, why have both? If I've got this unique identifier that the manufacturer stamped on it, why do I even need an IP address? So have a think about that for a sec, and I want you to pause the video and you can research it if you're completely stumped, but come back to me when you've got some thoughts about that. So pause, and you're back. So you can't change that MAC address. So think about a large network, and I mean a large network where you've got several hundred things. You've got printers, you've got rooms, workrooms, you've got different things, loads of switches and security and WAPs and loads of stuff. Now, if you could help identify to the human element, to the engineers, to the maintenance, to the people that run the network, use the IP addresses to kind of set groupings. So you might go 10.0.0.1 and 10.0.0.2 and 10.0.0.3. They're all the switches. So if I see at a quick glance on some kind of network administration that something's wrong with 10.0.0.3, I know one of my switches is down because I've kind of named them. You can force name the IP addresses on the network. And the same might go for if I use 10.0.1.1 and then 10.0.1.2. They might be the printers on the network. And you see how using this naming policy could help me identify devices at a glance from an administrational view or a maintenance view across the network. Now, if you use a MAC address, you've got no control over that, and they're going to be completely unique, and they could be completely different. So there's no way of grouping those together. So the IP address, one of the biggest advantages of having it is this kind of grouping and organizational factor, and that's the kind of main one I found when I looked into the question, because I had that's something I genuinely thought, what's the point of both? And if you can find any more, I'd be really interested to see what you've dug up on your research. So let me know if you found any other reasons as to why both exist. But that's a really good reason for having the IP addresses. So we've got standards and protocols. A standard, this is just something, it's not even a computing thing. This is just something, a standard is a set of rules which a group of people have agreed to follow in order to probably uh, ensure compatibility, ensure it's to a certain credibility or reliability. So if you think of something like, I'm trying to think of the most obvious thing in the UK, you might think of a power, a 3-pin plug. That's a standard. If you don't put a 3-pin plug on you think, oh, I've come up with a new cool plug, well, it wouldn't work, would it? So you've got to follow that standard. And there's hundreds upon thousands of standards, and there's loads just for computing. If you think about just any of you that have built any part of a computer or plug something in, the connectors, the way things work on the motherboard, the little slots, everything, they're all standards. They're things we've got to follow. So they're rules we follow in order to ensure this things work, ensure a bit of compatibility. And a protocol is a bit of an extension on that. So a protocol is a set of rules that govern, that control the way one device talks to another device across a network. So you could then think of it as a protocol really as a kind of standard. Um, and in this case, we've got a lot of protocols that we could refer to. And the one that you mostly need to know about is the TCP/IP protocol. So that's the main protocol we use across networks to move data around and talk between one device to another. So at the end, I'll be talking to you a little task I want you to do to do that. That's just some introduction stuff, but I will be getting you to look at that in more detail. The last big thing I want to look at is packet switching, which is to do with the TCP/IP protocol. So feel free to kind of, when you're looking at it at the end, to kind of use this as well in there. And packet switching is how we kind of move data and communicate across networks, and how it does it with large files. So if I want to grab a file, say off somebody else's computer on a network, and I'll grab a big file, and it's going to go from their terminal to mine via a couple of switches. It's how that file would move from their computer to mine, because it wouldn't happen in one big go. That's not what happens. What would happen is the computer that's sending that file would chop it into lots of agreed kind of set chunks. It would then add onto each chunk like a header saying, right, it's coming from this IP address, it's going to this IP address. It would add something called a checksum value, which we'll look at a different time to do with there's another bit of theory on that, but I'm not gonna. Again, you can look into it if you want, but it's for now it's a value which it's using for error checking purposes. So each time it moves from one node to another on the network, it performs a counter kind of checksum, and if the numbers don't kind of align, then there's been a error in transfer, and it will kind of resend that one packet. So each of these packet, let's say it's split a big file into 60, it's going to go, right, here's one of 60, so it'll number it. This is one of 60. It's going from this IP to this IP. Here's the checksum value, and here's all the data of this chunk, and that will send it. Now, the thing about how it sends it is it sends every one of those 60 little chunks with all of their headers, but it will send them at the best, most optimum, fastest route across the network at that given time. So they might, all 60 pieces might go flying from point of origin to where they're going to go, but they might all take different routes across the network depending on traffic on the network, which means they're not going to necessarily arrive in order, but because they're numbered and because they can be reassembled, that's what will happen on the other end. They'll just be rejiggered, built back up, and you've got your file back. The thing about the error checking is that happens on every single move. So from one node to another, as it's moving across the network, that checksum's performed, and if there's an error, it then resends that one packet before it moves on. And by doing that, you speed up actually the file transfer, because you now have, if something went wrong, if you sent the whole thing and something went wrong, well, you've got to send the whole thing again, right? If you're sending 60 tiny little pieces and something goes wrong on any of the stages, you just send that tiny little piece again. So the net gain is a massive speed increase of getting that file from A to B, and more reliably, you'll get it there without probably any error, because it will just resend where little errors occur until it gets to the end, and then you'll have the whole file again. So that's what it is. Please feel free to go out and look at an animation on that online to kind of get that right. And get it in your heads, because it's a lovely piece of theory. It's really easy to understand. Here's a little animation which you're free to kind of watch. I'll leave it on, but it just shows packets kind of moving across from one place to another, and all of these little things are like nodes on the network. They might arrive in the wrong order, and then it will rearrange them at the end, and the file will be back to normal again. But it's a lovely bit of theory. It's really easy to get your head around. So do make sure you've had a look at that. Now, extension and things for you to look at, I would like for you to kind of, bearing in mind, remember this video isn't just, you can't just watch this video and you're done. The guidance, remember, is about 3 to 4 hours a week, particularly if you're doing this when I made this video, it was during the COVID kind of stuff, so everyone's working from home, and so you guys watching this in the first instance, I would expect you to do these kind of things, and make sure you do put some time into this. So look at protocols, particularly things like, look at a few of the main protocols we use, like SMTP, POP3, and what else you got in there? IMAP. So those three are the kind of email-y kind of protocols. You might want to look at HTTP and HTTPS, and FTP for sending files. But the big one I want you to look at is the TCP/IP stack, and in particular, and this is where it can get a little hazy, is the layers. If you want a little help with this, again, I would advise watching the Craig and Dave videos. I'd also advise writing like something into YouTube, like network layers explained simply, and so you can watch some videos on it. They're very helpful if you can get it dumbed down a bit, because it's very technical if you go in a bit too heavy with this. So try and go and have a look at those things, and that's just going to kind of sharpen those areas. So I hope that's been useful. I hope that's a bit more interactive. I hope it's a bit more immersive. But please do those things. I would like you to upload to me some evidence of those factors here, that they have been done. So I want some like notes or revision materials that you produce on these aspects, so I know you have looked at those. And at some point, obviously, I'll be testing some of this via some kind of online test. So be aware of that. All of this stuff's gonna be kind of cross-checked and referenced. So thanks for listening. Hopefully it's been useful. I would appreciate some feedback on this kind of format of lesson. But until then, take care, stay safe.